Yeah, since I have to start the recording again, I'll just come from the beginning. So here it is. Multiply the powers, so it will be minus 3 by 4. Then how do you write the equivalent of this? Take the reciprocal of the base. So 7 by 1 becomes 1 by 7. And write the negative of the power, minus 3 by 4 plus 3 by 4. So this is nothing but 1 by 7 to the power 3 by 4, which can be written as 1 by 7 cubed, the whole power 1 by 4, which is 1 by 343 to the power 1 by 4. So the correct option is C, option C. Second one, which of the following is not equal to the given expression? Not equal to this. So we know that when the base is raised to multiple powers, the base is 5 by 7. It's raised to the power 1 by 3 and further raised to the power minus 1 by 4. So we'll have to multiply the powers. But look at this option, 5 by 7, and the powers are subtracted, 1 by 3 minus 1 by 4. So definitely this is not equal to this. The value of the given expression is not equal to this one. You don't have to check for the others because you'll have to find which of the following is not equal to this, right? What about A mini? Okay, so you want to understand the other options. We'll do it. Okay, so which of the following is not equal to this? So this one is not equal to. Option B is not equal to this one. Is that right? Option B is not equal to this one. Okay, then what about option A? So what has happened in option A? The power here is negative. The power here is negative. Here it is positive. And then the reciprocal of this expression is written here. Can you see that? The reciprocal of this expression is written here. How do you write equivalence? Now, if you have A by B to the power minus C by D. Now this is equal to D by A, the whole power C by D. Take the reciprocal of the base and write the negative of the power. In that case, you're writing the equivalent of this expression. The equivalent of this expression is this. But if you do only one of the two changes, now A by B, the whole power minus C by D. Supposing you write the reciprocal of the base, you write A by B as B by A. You take the reciprocal of the base, but you write the power as it is. Then they're not equal. Then this expression is the reciprocal of this expression. If you make only one of the two changes, the two changes are taking the reciprocal of the base and the other is writing the negative of the power. Reciprocal of the base, negative of the power. If you do both the changes at the same time, you are writing the equivalent of the given expression. If you write only one of the two, that is, you write the reciprocal of the base, but you write the power as it is, or you write the base as it is, but you write the negative of the power. So you are doing only one of the two changes. In that case, you're writing the reciprocal of the given expression. So the reciprocal of, no, I'm not answering this one. We're just recalling the reciprocal of A by B, the whole power minus C by D. Okay. The reciprocal of A by B, the whole power minus C by D. You can write it in two ways. If you write the base as it is, then write the negative of the power. If you write the power as it is, Write the reciprocal of the base. Now these two expressions are the reciprocals of the given expression. These two expressions are the reciprocals of the given expression. Why? So see here, this is the given expression. In the first case, we have written the base a by b as it is. Okay, so we don't make any change to the base, but the power minus c by d is written as plus c by d. So you've written the negative of the power, but you've written the base as it is. So that means this is the reciprocal of this expression. In the second one, you have written the reciprocal of the base. A by b is written as b by a. You have written the reciprocal of the base. You have not made any change to the power. You've written the power as it is, minus c by d. So you're making in both of these, you have made only one of the two changes, which means these expressions are reciprocals, or these expressions represent the reciprocals of the given expression. Yeah, you can make a note of this. Okay. Made a note, online students?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Yeah. Now let's answer this question. Which of the following is not equal to the expression given here? So very clearly, option B is not equal to this one. Because when there are many powers, that is when the base is raised to multiple powers, we'll have to multiply the powers. But here you see 1 by 3 minus 1 by 4. The difference is written. So clearly, this expression is not, or this expression is not equal to this expression. So option B is the correct option. Now let's understand the remaining options A, C, and D. Now 5 by 7, the whole power 1 by 3, the whole raised to the power minus 1 by 4. What do you see in option A? Minus 1 by 4 is written as plus 1 by 4. So negative of the power. Negative of the power. Minus 1 by 4 is written as plus 1 by 4. So negative of the power. So what do you do with the base? Or what do you do with the rest of it? Write the reciprocal of that. Write the reciprocal of that. So the rest of it, the reciprocal of this one. What's the reciprocal of this? Just put 1 by. 1 by. See? When you yeah. All right. So 1 by reciprocal of the base, and the power minus 1 by 4 is written as plus 1 by 4. So they're equal. Option A is equal to the given expression because they've applied both the changes. They've taken the reciprocal of the base as well as the negative of the power. I'll just show you again. Look at the power minus 1 by 4. In option A, the power is plus 1 by 4. All right. In option A, the power is plus 1 by 4. So clearly you can see the negative of the power. Minus 1 by 4 is written as plus 1 by 4. Then what do you do with the rest of it? You should take the reciprocal of the base. So what's the base there? 5 by 7 to the power 1 by 3. This, the rest of it, this one, this is the base. Write the reciprocal of the base. How do you write the reciprocal of the base? 1 over whatever is the base. Yeah. So 1 over 5 by 7, the whole power 1 by 3. This is the reciprocal of the base. The base there is 5. See, when you treat this as the power, when you treat this one as the power, the rest of it is treated as the base. When you take this one as the power, the rest of it is the base. So the base is 5 by 7 to the power 1 by 3. Reciprocal of the base, 1 by 5 by 7, the whole power 1 by 3. Reciprocal of the base. Now negative of the power. What is the power there? Minus 1 by 4. So here it should be written as plus 1 by 4. That means these two expressions are equal because you have applied both the changes. So option A is equal to the given expression. No, option A is equal to the given expression. Then option B is not equal to the given expression. What about option C? In option C, 5 by 7. So when you evaluate the given expression, you'll have to multiply the powers. So when you multiply the powers, you have 1 by 3 into minus 1 by 4. So it is 5 by 7 to the power minus 1 by 12. That's what you see in option C. So equal. Option C is equal to the given expression. And option D, you can see the reciprocal of the base 7 by 5 and the negative of the power 1 by 12. Again equal. Options A, C, and D, the expression on option A, option C, and option D are equal to the given expression. This is option C. Now 5 by 7, reciprocal of 5 by 7, 7 by 5. Negative of the power, minus 1 by 12 plus 1 by 2. So these options are equal to the given expression. Option B is not equal to the given expression. Yeah. How do we do this? What's the rule? When base are same and its multiplication, we'll have to add the powers. Add the powers. Zero 0.5 online students. 0.5 can be written as 5 by
10.
5 by 10.
2.
5 by 10. And 5 by 10 simplifies to
1 by 2.
1 by 2. And 144 can be written as
Root of
12 squared.
12.
12 squared.
12.
144 is 12 squared into 1 by 2. Very good. Correct. Rahul, take the table closer to you. Take the table closer to you. All right. Next one. Fourth root of cube root of 2 square. Option D. C. Okay. Yes. Okay. So this simple fourth root in the exponential form is to the power 1 by 4. Correct? Fourth root in the exponential form is to the power 1 by 4. So then what will remain? Cube root of square root of 2 square. You can write it as 4 also. You can write it as 4. I'm not writing it. You can also write it as 4. Okay, now we'll remove the cube root symbol. So there's already power 1 by 4. Now when you take away the cube root symbol, it will be raised to the power 1 by 3. But when there are many powers, you'll have to multiply the powers. So into 1 by 3. So now what remains? Square root of 2 square. Square root of 2 square is 2. Yeah. Want you can write 2 square as 4. So now the cube root is written as to the power 1 by 3. So what remains there? Square root of 4 remains there, right? This remains. Now what is square root of 4? 2. And 2 to the power 1 by 12. Option C is the correct option. Very good. Done writing? Online children?
Yes, ma'am.
Okay.
Hi, Smriti, ma'am. I have joined now. Is it a test, ma'am?
Sai Smriti, disable your mic. Okay. So we'll have to multiply 5 into cube root of 4 by square root of 3. Okay. See, now if you have cube root of 4 multiplied by cube root of 3, you can write it as cube root of 4 into 3. If you have to multiply cube root of 4 and cube root of 3, then it is cube root of 4 into 3. But here it is cube root of 4 multiplied by square root of 3. So you'll have to bring them to the same order. The order here is 3. The order here is 2. You'll have to bring the surds to the same order. You'll have to bring the surds to the same order. And the same order will be the LCM of the given orders. The same order will be the LCM of the given orders. What's the order here? 3. What's the order here? 2. What's the LCM of 3 and 2? 6. So you'll have to bring both the surds to order 6. and then you can multiply. I'll tell you again. Please listen. Now here, this surd is of order 3. This surd is of order 2. These are two surds of different orders, so you cannot multiply them. Then how can you multiply? You'll have to bring them to the same order. And what is that same order? The same order, to bring them to the same order, use the LCM of the given orders. So order 3, order 2. LCM of 3 and 2, 6. So bring both the surds to order 6 and then you can multiply. Okay. So see here, cube root of 4 can be written as 4 to the power 1 by 3. And this can be written as square root of 3 can be written as 3 to the power 1 by 2. Now we will have to bring it to order 6. So how will the denominator 3 become 6? How will the denominator 3 become 6? You will have to multiply and divide by 2. Correct? How will the denominator 3 become 6? Multiply and divide by 2. How will the denominator 2 become 6? Multiply and divide by 3. Okay, so we are writing equivalent fractions. So 5 into 1 into 2 is 2, 3 to the 6. 1 3s are 3, 2 3s are 6. So now we have 2 by 6 and 3 by 6. Now this is nothing but, I can just add one more step. So this is 5 into 4 square, the whole power 1 by 6 into 3 cubed, the whole power 1 by 6. You can just insert this step. Correct? 4 to the power 2 by 6 is nothing but 4 square, the whole power 1 by 6. And 3 to the power 3 by 6 is 3 cubed, the whole power 1 by 6. Now 1 by 6 is 6th root. 1 by 6 is nothing but 6th root. So 5 as it is. 1 by 6, the power 1 by 6 is written as the 6th root of 4 square. 4 square. Power 1 by 6, 6th root of 3 cube. 3 cube. So 4 square is 16, 3 cube is 27. Now you can see that the surds are of the same order 6. Now you can multiply 5 into 6th root of 16 into 27. And 16 into 27 is 432. So the product is 5 6th root of 432. Yeah, please work. Why are you writing in this corner? There's so much space, no, in the middle. Any questions here? Online children?
No, ma'am.
No, ma'am.
Okay, let's do it again. Tell me, online children. Don't read from your book. Look at the screen and answer. So what's the first step? 5 into 4 to the power
1 by
3
by
as the
Into?
exponent into
3
3
into 1 by 3 to the
1 by
3 to the
2
power
as
1
the
by 2.
exponent.
Yeah.
Power. Yeah.
So what's the LCM of 3 and 2?
6.
6. So we'll have to bring both the fractions to denominator 6. We'll have to bring both the fractions or the powers to denominator 6. So 5 into multiply and divide by 2, correct?
Yes, ma'am.
And here multiply and divide by 3.
3.
So it'll be 5 into 4 to the power 2 by 6 into 3 to the power 3 by 6.
3 by 6.
And 2 by 6 can be written as 2 into 1 by 6. 2 by 6 can be written as 2 into 1 by 6. So it will be 4 square, the whole power 1 by 6. 2 into 1 by 6. Into 3 cubed, the whole power 1 by 6. Okay, so this is nothing but 5 into 6th root of 4 squared into 6th root of 3 cubed. So it is 5 into 6th root of 4 square is 16 and 3 cubed is 27. So 5 into 6th root of 16 into 27 is 432. This is the next one. It means multiplication. Multiplication. Cube root of 3 into 4th root of 3 into 12th root of 243. So how do you write cube root of 3 in the exponential form? How do we write cube root of 3 in the exponential form?
1 by
3
3.
to the power 1 by 3.
3 to the power 1 by 3. Very good. Into 4th root of 3 in the exponential form.
3 to the power 1 by 4.
Correct. Into what is 243? 3 to the power 5. 243 is 3 to the power 5 into 1 by 12. Into 1 by 12. So it's 3 to the power 1 by 3 into 3 to the power 1 by 4 into 3 to the power 5 by 12. Bases are same and it's multiplication. So you just have to add the powers. The bases are same and it's multiplication. So add the powers. 3 to the power 1 by 3 plus 1 by 4 plus 5 by 12. Okay. So 12 is a common denominator. 12 is a common denominator. So it will be 4 plus 3 plus 5. So 3 to the power 12 by 12. So 3 to the power 1, which is 3. Right on.
Done, ma'am.
Yeah. So cube root of 3 can be written as
3 to the power 1 by 3.
3 to the power 1 by 3. And fourth root of 3?
3 to the power 1 by 4.
And what's 243 in base 3?
3 to
243
the power
in base
5.
3.
To the power 5.
5. And 12th root is to the power 1 by 12. So it will be
1 by
into 1 by
12.
12. Base are same and it's multiplication. So we'll have to add the powers. So it will be 3 to the power 1 by 3 plus 1 by 4 plus 5 by 12. So take the LCM and simplify. You get 3 to the power 12 by 12. 3 to the power 1, which is 3. Yeah, this is the next one. Yeah, this you can help yourself. Oh, I don't have the answer. Okay. Okay, so why don't I give this as homework? We just did a similar one. Try this as homework. We'll see the answer in the next class. Take down the question. Take down the question. We'll see the answer in the next class.
Done copying, ma'am.
Yeah. We'll do this now. Arrange in descending order. Very simple. You just have to bring all the surds to the same order. Now we have 4 surds here. All the 4 are of different orders. So the LCM of 3, 4, 6, and 12 is 12. So bring all the surds to the same order 12. And then you can arrange them in the ascending or descending order. Sorry? Using the correct. Yeah. So you'll have to work them separately. Cube root of 2 is nothing but 2 to the power 1 by 3. We'll have to bring all the surds to order 12 because the LCM of 3, 4, 6, and 12 is 12. So you'll have to multiply and divide by 4. Tell me the next one, Wahid. Fourth root of 5. So how do you write this? 5 to the power 1 by 4. Now you will have to bring the denominator to 12 because the LCM is 12. So you'll have to multiply and divide by 3. By 3. So it's 5 to the power 3 by 12. And 3 by 12 can be written as
It can be written as 1 by 4, ma'am.
3
Sorry?
into 1 by 12.
Please come again. Yeah, tell me. 12th root of, what is the 12th root of? No. 5 into 5 is 25. 25 into 5, 125. Yeah, work the others. Yeah, you tell me. 6th root of 7 is equal to the power 1 by 6. What is the required denominator? What's the required denominator? 12, right? So you have 6. It should be 12. So you'll have to multiply and divide by 2. So this is correct. Yeah, next. 7 to the power 2 into 1 by 12. So it's a 12th root of 7 square. Very good. The last one is already a third of order 12. The last one is 12th root of 3. So that you don't have to make any changes. So we have, which one comes first? Descending order. Big to small. Which is the biggest?
12th root of 125.
12th root of 125. So 12th root of 125 is greater than 12th root of 49 is greater than 12th root of 16 is greater than 12th root of 3. Now write the given expressions. So 12th root of 125 is 4th root of 5 is greater than 12th root of 49 is 6th root of 7 greater than cube root of 2 is greater than 12th root of 3. Very good. Please don't miss any step. Take down the answer as you see on the screen. Okay, next one. So this we've already done earlier. 1 second. Yeah, try this. No, you're confused with this one. This one? No, we've done this earlier. Yeah. Which one? Yeah, try this. Five to the power n plus 2. N plus 2. What's answer? Minus 5 by 3. Okay. Now 5 to the power n plus 2. Five to the power n plus 2 can be written as 5 to the power n into 5 to the power 2.
5 to the power 2.
Correct. Minus 6 into 5 to the power n plus 1 can be written as 5 to the power n into 5 to the power 1 divided by 13 into 5 to the power n minus 2 into 5 to the power n plus 1 is 5 to the power n into 5 to the power 1. Why? Because 5 to the power n into 5 to the power 1 bases are same and it's multiplication. So we'll have to add the powers. So 5 to the power n plus 1. So 5 to the power n plus 1 can be written as 5 to the power n into 5 to the power 1. Okay. So we are taking out 5 to the power n common. Because in both the numerator and denominator, you can see 5 to the power n. You can see 5 to the power n in both the numerator and denominator. So we'll take out 5 to the power n common in the numerator and in the denominator. So 5 to the power n common, open bracket. So this is the first expression. 5 to the power n is out common. So you'll have 5 square inside the bracket as the first term. Minus 5 to the power n is out common. See, this is the second expression. 5 to the power n is common. So 6 into 5. In the bracket, you will have 6 into 5. 6 into 5 divided by 5 to the power n common. In the denominator, this is the first expression. So 5 to the power n is common. So you'll have 13 minus, this is the second term in the denominator. And 5 to the power n is common. So you'll have 2 into 5.
5.
So 5 power n in the numerator and denominator gets cancelled. So we have 25 minus 30. 5 square is 25 minus 30 divided by 13 minus 10, which is minus 5 by 3. Minus 5 by 3. If you want. No, you can sit this side if you want, I said. Done, all of you? Finished? Finished?
Yes, ma'am.
Yeah, try this one. What's 128 in base 2? 128 is equal to 2 raised to the power 7. Correct. 2 to the power 6 is 64. 2 to the power 7 is 128. Correct. And what's 625 in base 5? 5 to the power 4. And 2401 is what to the base is what to the power 4? 7. That was a guess. Yes. 7 to the power 4. Done, children? No?
Done, ma'am.
Rahul, you have a doubt? Okay. Okay, so 128 is 2 to the power 7. There's already this power minus 2 by 7. So multiplied by minus 2 by 7. 128 is 2 to the power 7. And the power here. So multiply into minus 2 by 7. Minus 625 is 5 to the power 4. And then you have the powers minus 3 and minus 1 by 4. Minus 3 and minus 1 by 4. Multiply the powers. Then this 14. 2401. 2401 is 7. 343 times. 7. 49 times. 7 sevens are 7 ones are. So 2401 is 7 to the power 4. 2401 is 7 to the power 4. So 14 into 2401 is 7 to the power 4. And it's raised to the power minus 1 by 4. So multiply the powers. 7 power 4 into minus 1 by 4. Now the 7 and 7 gets cancelled. 4 and 4 gets cancelled. 4 and 4 gets cancelled. So we have 2 to the power minus 2. Excuse me. Yeah, I was talking about the cancelling part. So then after that, we have 2 to the power minus 2, 5 raised to the power minus 3 into minus 1. So it's plus 3, 5 to the power 3. And here 14 into 7 to the power minus 1. 2 to the power minus 2 is 1 by 2 squared minus 5 cube plus 14 into 7 to the power minus 1 is 1 by 7. So 1 by 4 minus 5 cube is 125. And here 7 ones are 7 twos are. So plus 2. Minus 125 plus 2 is minus 123. 1 by 4 minus 123. Take the common denominator. 4. And the answer is minus 491 by 4. Yeah, do this one. Good. Coming. Very good. Here you forgotten to write the denominator. Here. Correct. Very good. Yeah. Completed? Online children?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Yeah, try this one. So when we did this sum earlier, we have taken out 2x minus 2 common. Now let's take out 2x minus 1 common. When I did this sum earlier, we have understood by taking out 2x minus 2 common. Now let's take out 2x minus 1 common. 5 to the power 2x minus 1 common. So in the bracket, you will have 1 minus. Now 5 to the power 2x minus 1 multiplied by 5 to the power what will give you 5 to the power 2x minus 2. We have taken out 5 to the power 2x minus 1 common. 2x minus 1 common. Multiplied by what? Multiplied by 5 raised to the power what will give you 5 raised to the power 2x minus 2. Here we have 5 to the power 2x minus 1. Here we have 5 to the power 2x minus 2. We have taken out 5 to the power 2x minus 1 common. So this into 1 will give you the first term. Minus. Now this into what will give you 5 to the power 2x minus 2. Sorry. 1 by?
Is it 2?
2 is it? Okay, let's just try that. If you put a 2 here, then 2x minus 1 plus 2. It will be 2x minus 1 plus 2. Add the power. So you will get 2x plus 1. But you should get 2x minus 2. No, you don't understand the entire thing, right? Minus 2. Minus 1. Correct. Correct. That should be 5 to the power minus 1. Now when you add the powers, it will be 2x minus 1 minus 1. So 2x minus 2. So in the bracket, the second term will be 5 to the power minus 1. Five to the power 2x minus 1 into 1 will give you the first term, 5 to the power 2x minus 1. Now 5 to the power 2x minus 1 into what? will give you the second term, 5 to the power 2x minus 2. So that's what we have tried here. 5 to the power 2x minus 1 into what? Will give you 5 to the power 2x minus 2. So the answer is 5 to the power minus 1. Now add the powers 2x minus 1 minus 1. 2x minus 2. So we have 5 to the power 2x minus 1. 1 minus 5 to the power minus 1 is 1 by 5 is equal to 2500. Five to the power 2x minus 1 into 1 minus 1 by 5 LCM 4 by 5. 1 minus 1 by 5. Upon taking the LCM, you'll get 5 minus 1 by 5. So 5 to the power 2x minus 1 into 4 by 5 is equal to 2500. 5 to the power 2x minus 1 is equal to 2500 into 5 by 4. 4 by 5 becomes 5 by 4 on the other side. 4 ones are 4 6 are 24, 1 remains. 4 2s are 8, 2 remains. 4 5s are. Now 5 to the power 2x minus 1 is equal to 625 is 5 to the power 4 into 5. So 5 to the power 2x minus 1 is equal to 5 to the power 5. 4 plus 1, 5. Now we equate the powers. I'll work it here. Equate the powers. So 2x minus 1 is equal to 5. 2x is equal to 6. X is equal to 3. Base are same on both the sides. So 2x minus 1 is equal to 5. 2x is equal to 6. X is equal to 3. Done, children?
Just a minute,
One
ma'am.
man.
Okay, okay.
Please writing, ma'am. Yes, ma'am.
Okay.
Completed.
Yeah, work this one. If root 7 is equal to 2.646, find the value of 1 by root 7. Finished? So in order to find the value of 1 by root 7, the denominator is irrational. So you'll have to rationalize the denominator. We need to find the value of 1 by root 7. The denominator is irrational. So we'll have to rationalize the denominator. Multiply and divide by root 7. So we have root 7 by 7. Now we use the value 2.646 by 7. First, rationalize the denominator. So we have root 7 by 7. Now take the value given. The value of root 7 is 2.646 divided by 7. Perform the long division. 2.646 divided by 7. And the value is 0.378. And next one. Done? Yeah. This is the next question. So we need to first simplify the given expression. Before we find its value, we'll have to first simplify this. So square root of root 2 minus 1 by root 2 plus 1. So the conjugate of root 2 plus 1 is root 2 minus 1. So multiply and divide by root 2 minus 1. Multiply and divide by root 2 minus 1. The denominator is root 2 plus 1. Before we find the value of the given expression, we'll have to simplify it. So in the denominator, we have root 2 plus 1. Its conjugate is root 2 minus 1. So multiply and divide by root 2 minus 1. So you get square root of root 2 minus 1 the whole square. Root 2 minus 1 into root 2 minus 1 is root 2 minus 1 the whole square. Divided by the denominator is a plus b into a minus b. So a squared minus b squared. Root 2 the whole square minus 1 the whole square. So square root of, don't expand this, root 2 minus 1 the whole square divided by root 2 square is 2 minus 1 square is 1. So that is 2 minus 1 is 2 minus 1 is 1. So we have square root of root 2 minus 1 the whole square, which is nothing but root 2 minus 1. Square root of root 2 minus 1 the whole square. So we have under the square root, we have root 2 minus 1 into root 2 minus 1. Under the square root, we have root 2 minus 1 into root 2 minus 1. We have it 2 times. So its square root is root 2 minus 1. Now the value of root 2 is given to us 1.414 minus 1, which is 0.414. See, if you have a doubt here with this one, it is root of, under the square root, you have root 2 minus 1 2 times. Root 2 minus 1 into root 2 minus 1. So square root of root 2 minus 1 into root 2 minus 1 is root 2 minus 1. One of it will come out of the square root. So before you find the value of the given expression, you'll have to simplify it. We'll have to find the value of this one. But before you find the value of this one, you'll have to simplify it. Simplify and then apply the value of root 2 given. Finished, all of you? Yeah.
Yes, ma'am. Yeah, ma'am.
So look at this one. Evaluate 1 by root 3 minus root 2 minus 1, given that root 2 is 1.414 and root 6 is 2.44. So again, you will have to rationalize the denominator. You'll have to rationalize the denominator. You'll have to simplify this one and then use these values given. Yeah. I presented the answer. Please go through the answer and work it yourself. I'll just help you get started. So to simplify the expression given, the denominator has 3 terms. So enclose a bracket for the first 2 terms. Enclose the first 2 terms in a bracket. The first 2 terms. See, we have root 3 minus root 2 minus 1. There are 3 terms. Enclose a bracket for the first 2 terms. So root 3 minus root 2 minus 1. So now this is like A minus B. Like this is one term minus this is a second term. So what will be the conjugate of this one? Write this one as it is. Write this as it is. Write this one also as it is. The connecting sign here is minus. It will be plus in the conjugate. It will be plus in the conjugate. Yes or no? Write these as it is. Root 3 minus root 2. Root 3 minus root 2. 1, 1. Here the connecting sign is minus. The conjugate will have a plus. That's the first step. Now multiply the numerators, multiply the denominators. So the denominators of the form A minus B into A plus B. So you can see the result is A squared minus B squared. This is A minus B. A minus B into A plus B. So the result is A squared minus B squared. Then you'll have to expand this one. Root 3 minus root 2 the whole square. Like A minus B the whole square. So it's A square plus B square minus 2AB. A square plus B square minus 2AB. Minus 1. So on simplifying this, you get 4 minus 2 root 6. You can take out 2 common. So you get 2 minus root 6. Now again, the denominator is irrational. Rational is a denominator. So 2 minus root 6. Its conjugate is 2 plus root 6. So multiply and divide by 2 plus root 6. Again, multiply the numerators. Multiply the denominators. So multiplying the numerators will be root 3 minus root 2 plus 1 into 2 plus root 6. Divided by 2 into 2 minus root 6 into 2 plus root 6. Multiply the numerators, multiply the denominators. So how do you now proceed? Multiply every term with a second bracket. Root 3, multiply every term in the first bracket with the second bracket. So it will be root 3 into 2 plus root 6 minus root 2 into 2 plus root 6 plus 1 into 2 plus root 6. Multiply every term in the first bracket with the second bracket. And here this is A minus B into A plus B. So again A squared minus B squared. So after multiplying, you'll have to express, the surds as a mixed surd. And then you can see plus 2 root 3 and minus 2 root 3 gets cancelled. So we have these 3 terms in the numerator divided by minus 4. Now the denominator is rational. It was irrational earlier. Now it's rational. Now you can apply the values given in the question. They are given that root 2 is 1.414 and root 6 is 2.44. Once you have rationalized the denominator, you can apply these values. And you can see the minus sign in the denominator. You can see the minus here in the denominator. Take it up to the numerator. So it will become minus root 2 minus root 6 minus 2 by 4. You should apply the minus sign to every term in the numerator. You can just include the step if you want. Take the minus to the numerator, so it will become by 4 like this. Between these two steps, you can take this step. Take the minus to the numerator. There will be minus of root 2 plus root 6 plus 2 by 4. So now when you open the bracket, it will be minus root 2, minus root 6, minus 2 by 4. Now use the values given in the question and simplify. It's an important question. Yeah, work this carefully. To your parent. No way. Oh. Finished? Please understand as you work. In today's class, we just recalled a few situations which we've already worked earlier. So in the next class, we'll take a bunch of questions from exponents, very important questions from exponents. Today's class was a repetition of questions which we have seen earlier. So from the next class, we'll go ahead. So as I told you, next class we'll be taking up a set of questions from exponents, which are very important from the examination and the concept point of view. Very important concepts used in solving those questions. Finish this one, all of you?
Yes.
Online children, done working this one? Please ask me.
Yes.
Any part not clear, please ask me. Rahul? Nuved? Any questions? Hari Darshan, right? Yeah, this is the next question. Yeah, please work this one. Yeah, what are the values of X and Y? Found? So how do you get started? How do you start working this answer? Correct. You just have to rationalize the denominator on the left-hand side. The denominator is 3 plus 2 root 5. Multiply and divide by its conjugate 3 minus 2 root 5. The RHS should be written as it is, x root 5 minus y by 11 as it is. 14. And x is? No. Minus? The RHS is written as it is. Don't do anything with the RHS. See here, RHS is written as it is. We're going to work only the LHS. In the LHS, the denominator is irrational. So we'll perform the procedure. We'll work the steps to rationalize the denominator. The denominator is 3 plus 2 root 5. Its conjugate is 3 minus 2 root 5. So multiply and divide by 3 minus 2 root 5. Then multiply the numerators, multiply the denominators. So in the numerator, you cannot use any formula. So first term into the second bracket, second term into the second bracket. The denominator is of the form a plus b into a minus b. So the result is a squared minus b squared. In the numerator, no formula. You'll have to multiply these two brackets, the terms in these two brackets. So multiply the first term with the second bracket. 3 multiplied by the second bracket minus root 5 multiplied by the second bracket. The denominator is a plus b into a minus b. So the result is a squared minus b squared. So that gives you 9 minus 20 or minus 11. And in the numerator, we have minus 9 root 5 plus 19 by minus 11 in the denominator. So I've taken minus common. I've taken out minus common in the numerator and denominator. You can work it like this also. You can take out a minus common, or I have taken this minus up to the numerator here. This is minus 11, right? This is minus 11. I've taken the minus up to the numerator. So you can see here. I put this in a bracket. Minus 9 root 5 plus 19. I've taken this minus to the numerator here. Minus. This minus to the numerator. So it's a plus 11 here. The minus is here. So now open the bracket. It will be plus 9 root 5 minus 19. Minus into plus minus 19 by 11. So now there's nothing but 9 root 5 by 11 minus 19 by 11. 9 root 5 by 11 minus 19 by 11 is equal to x root 5 minus y by 11. Now compare the left hand side and the right hand side. Compare the LHS and RHS. X root 5 is equal to 9 root 5 by 11. So root 5 and root 5 gets cancelled. X is equal to 9 by 11. Similarly, minus y by 11 is equal to minus 19 by 11. So minus minus cancels, 11 cancels, y is equal to 19. Yeah. Any questions? Online children? Lakshana, Aishwarya, Gayatri, Surya, Yarni, Harsha, and Sai Smriti. Any questions?
No, ma'am.
No, ma'am.
Working or completed?
Working, ma'am.
Okay, yeah. All right. Okay, take a screenshot if you have not completed.
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you, children. Online children can leave the call. Good night.
Thank you, ma'am. Good night.
Thank you. Good
Thank
night.
you, ma'am.
Thank you. Good night.